Good afternoon. I'm Scott Arnold, Senior Manager of Publications and Standards for AMCA International. Welcome to Fan Efficiency Codes and Regulations. What the heck is happening now? This session is worth one professional development hour. To earn that credit, there are three things you must do. One is have your attendance recorded. If your badge was not scanned on your way into the room, please see the room monitor on your way out, and she'll be sure that it gets scanned. Second, you need to be present for the entire session. And third, you need to complete a post-session evaluation. The last slide of the presentation will have a QR code. You can scan it with your phone and complete the survey today, or in a few weeks, once we get the attendance list, we'll send out a thank you email, and that will include a link to the survey as well as the slides for this presentation. In preparing this session, AMCA met the standards and requirements of Registered Continuing Education Program, or RCEP. RCEP's involvement should not be deemed or construed to be an approval or endorsement of the content of this session. The information contained in this session is provided by AMCA as an educational service. In making this educational activity available, AMCA is not endorsing, sponsoring, or recommending a particular company, product, or application. This session is protected by U.S. international copyright laws. Reproduction, distribution, display, and use of the material without written permission from AMCA International is prohibited. And with all that out of the way, let's meet our presenters. Brittany Swan serves as Regulatory Affairs Analyst in AMCA International's Advocacy Department. She has 13 years of experience in regulatory affairs, with a background spanning the gaming and higher education industries. She joined AMCA in late 2024 and since has contributed to several key initiatives, including the Unification Project and the Environmental Product Declaration Working Group. She currently acts as liaison for both the Air Movement and Air Control Code Action and Review Committees, along with their respective subcommittees and working groups. First, though, we'll be hearing from Michael Ivanovic. Michael is Senior Director, Advocacy and Education for AMCA International. In this role, he works with committees in North America, Asia, Europe, and the Middle East to develop strategies and programs that manifest the mission of the association to advance the knowledge, growth, and integrity of the air movement and control industry. Michael?
Welcome. Thanks a lot for joining us here today. This is going to be a fun presentation. I see some familiar faces. I'm not going to ask you all to introduce yourselves. We don't have enough time, but we do have some people visiting us from our laboratory, our accredited laboratory in South Korea. Thank you very much for joining us. We have others from other parts of the country as well. So this really is an international audience. What I'm going to be covering, the learning objectives are going to be, we're going to talk a little bit about the U.S. federal fan regulations. They finally hit a milestone, not a very good one. They had an energy standard that they drafted, published, public review, and then they took it back. But we'll talk about where that's at. We'll talk about state fan energy codes and regulations as well. There's a lot going on in states. We'll talk about the updates that we propose to make to the model energy codes and several state energy codes that had their code update cycles happening at the same time as the model energy codes. And we'll talk a little bit about that. And then I really hope to impress upon you the utility and benefits of specifying third-party rated fan ratings for your specifications, because it's one way to cut through all the noise that's going on in fan code standards and regulations. Probably your best defense is to specify AMCA certified fans. We'll talk about that. So those are the learning objectives for today. In terms of an outline, first of all, I'm going to cut to the chase. I don't normally do that, and usually people leave halfway through my presentation so they don't get to the punchline. But we're not going to do that this time. I'm going to head you off at the pass. Then we're going to talk about the Fan Efficiency Regulation Unification Project. Brittany's going to be covering that. She did a fantastic job with that effort. And then also model and state energy codes. I'll pick up on that. And then I'll close with reiterating the part about specification. So, to cut to the chase. I did an analysis of the construction permit data for 2024, worked with a contractor to do that, and we looked at, there's an organization that publishes something called Construct Connect, which is a huge database of permit data. And one of the things we looked for was the specification frequency for FEI in construction permits for commercial buildings. There was only 400 in the country in 2024. And I was really blown away by that. And so I started looking at the actual specifications, and, quite a few of them did have AMCA certification, of course, but by and large, there's just so few that mentioned the metric FEI or specified a minimum FEI rating for the fans in those specifications. And so I really think it's important for you to know that you can do that, all right? And I'm going to give you the language for doing that. You can take a picture of the screen if you want, or give me your card and I'll send it to you. But basically, when it's possible to specify third-party products generally, not just AMCA, but AHRI, of course, Hydraulic Institute for Pumps, third-party ratings have a lot of advantage, and I'll talk about that in a second. But that's what I wanted you to know. And I'll show you the exact specific language. This is kind of a short term of it, but fans shall be licensed to bear the AMCA Certified Ratings Program seal for air performance and fan energy index. I got some language later on that's got a little bit more specification than that. But anyway, we did make it easy for you to find AMCA certified FEI fans with this URL. It shortcuts all of the searching you might have to do on our database, and it's easy to remember, amca.org/findFEI, with a hyphen in there. So anyway, there's that. But the real question is why would I ask you to do that with integrity? Okay, not just pumping up AMCA. I'm not doing that. Okay. There is a federal test procedure for fans. It's been in place since October 2023. It's been effective. It was published before that, but it became effective. And on that effective date, all the fans that have an efficiency representation, like either FEG or FEI, fan energy grade, fan energy index, fan efficiency grade, whatever, the brake horsepower, right, static efficiency, total efficiency, any energy performance metric for fans after that date had to be in accordance, been derived for calculations and testing in accordance with the federal test procedure. So that's been in place now for well over 2 years, but that isn't being enforced by DOE. It just isn't. So if you specify AMCA certified fans, then those fans will have been tested in accordance with the test procedure. It's kind of like a shorthand way of making sure that those fans have a rating that complies with the law, okay? There is no federal energy requirement for commercial and industrial fans, so that comes out from an energy standard. First comes the test procedure, and then comes an energy standard, and along with that, usually the compliance filing requirements and the enforcement provisions. Well, DOE published the draft, but then they pulled it back on the final, so there is no minimum federal requirements. There's also the same for air circulating fans. Late in the program for DOE, they said, well, we're going to regulate air circulating fans too. Those are circulating fans that you would see like man coolers and things like that, axial fans with a cage. And so those are also have a test procedure now and no minimum energy requirement. California has a regulation for commercial industrial fans, but they don't have one for air circulating fans. So things are just kind of messy in terms of things are different everywhere you go. State energy codes for commercial fans, where they exist, they're inconsistent concerning metrics. I'm going to show that later on. And then the first ever provisions for air circulating fans. This is a new thing. They're going into the model energy codes and a couple of state energy codes now. Those are inconsistent as well. So basically, in my view, fan energy codes and regulations, they're a mess. They're all over the place everywhere you go. So that's one of the reasons why specification for AMCA certified is a way of providing a consistent basis for getting kind of what you're looking for. And those fans, as I mentioned, are tested to the DOE test procedure. So that's your best chance of getting compliant fans. And the ratings are also accurate. But the other thing, too, is let's be real. One of the things about certification is that those tests are performed in accordance with laboratory conditions. So I found a picture of a fan being applied in the real world that is not going to operate with performance ratings consistent with those in a laboratory condition. If you look at that right angle coming off that fan outlet, you know there's going to be system effect in there. Those of you who took the first session today, we did system effect, right? So you'll know, like that fan is just not going to have the energy performance characteristics of a fan tested in laboratory conditions. It might be AMCA certified, probably isn't because it's an industrial fan, but still, you just have to understand that the ratings that you get are not going to match those in real world, but in terms of being able to compare fan performance across manufacturers and things like that, your best chance of getting accurate ratings is from certification. Anyway, so let's talk about the fan unification project. This is the way that we went about dealing with DOE doing what they did to us. So ladies and gentlemen, Brittany Swan.
Hi, everyone. So Michael said fan efficiency is a mess. I don't think you really captured the degree of the mess that actually occurred. So when we say the word mess, we know it's not really a mild inconvenience. It's more a spreadsheet with no version control. So chaos. But don't worry, we're going to unpack that by talking about our recently completed unification project. So let's start with the timeline, because if there's one thing we love more than fans, it's chronology. Around 2010, AHR and AMCA collaborated on a baseline requirement for fan efficiency, resulting in a metric called Fan Efficiency Grade, or FEG. FEG first appeared in AHR 90.1 in the 2013 edition. So back when we all thought we were on a clear and orderly path forward, spoiler alert, we weren't, so we still had a lot of work to do. While this was happening, DOE started fan efficiency rulemaking in 2011, which eventually led to the Fan Energy Index, or FEI, being developed to replace FEG. So DOE more or less selected FEI in 2015 as part of its federal fan regulation. So I know we're skipping a lot here, we're blurring some lines. Think of this as the previously on fan efficiency episode. If you do have further questions, please catch Michael or I at the end of the presentation. We're happy to assist you. So in 2013, DOE published the final rule for its FEI-based test procedure, which took effect on October 30th, and along the way, it picked up the air circulating fans rulemaking, so like Michael mentioned earlier. The DOE test procedures establish the method of test, the efficiency metrics, and the requirement that energy representations for covered products use those metrics and methods. So the minimum energy performance requirements come in later in an energy standard along with compliance filing and enforcement provisions. These are actually separate regulations, though they're usually published simultaneously when a product is regulated for the first time, as in the case with fans. So here's something to raise your eyebrows, and wait for the cue. No preemptive eyebrow raising, please. The test standard, the draft standard only, there was no compliance or enforcement provision, so that was established in January 2024. Now this drew substantial public comment from AMCA with other stakeholders, so here's your cue to raise your eyebrows. No compliance, no enforcement standards. In its withdrawal statement, DOE encouraged states to craft their own regulations. Now this is nearly 14 years after DOE started rulemaking. So in essence, DOE spent over a decade working on fan efficiency and then said, good luck everybody, and threw fan efficiency to the wolves. Cue spicy picture. Meanwhile, because the fan efficiency metric changed from FEG to FEI, state energy codes now contain a mix of both metrics. And since DOE's draft energy standard was public, Washington State revised the energy code to align with that draft even after the federal rule was withdrawn. So we said it was a mess. Which means that Washington is now using an approach that's completely different from any other one used by most other energy codes. So think of it, same destination, different maps, missing some street signs here and there. So faced with state-by-state regulations, and California already having one, more on that later, AMCA worked with other stakeholders to create a template to help with harmonization to the greatest extent possible. So we call this the Fan Efficiency Regulation Unification Project. I know it's a very long name, Unification Project for short. I'm happy to report that this was started and finished in less than a year. So by code standards, that's basically a sprint. You're not going to see me sprint across the stage. I'm not a runner, so catch that later. We created two committees, one for commercial and industrial fans and blowers, and one for air circulating fans, simply because each required different subject matter experts in the fan industry. Both were eventually gathered under the same unification umbrella, though. AMCA's unification team positioned the resulting regulation template, starting point for proposals to AHR 90.1, the IECC, and state energy codes, with the goal of eventually harmonizing code provisions. It was also designed to serve as a starting reference for utility incentive programs when crafting rebates. So our unification project participants. So as mentioned earlier, we gathered stakeholders from across our industry. AMCA and its members through consensus and internal committees. And at this point, I would like to say a huge thank you to our chairs. So chair of our commercial industrial fans and blowers was initially Mark Bublitz of New York Blower, and then he eventually handed off his chairmanship to Ken Kuntz of Green Heck. Both did a phenomenal job in leading the charge. And then Caitlin Stoker of Big Ass Fans led the air circulating fan working group. We also joined forces with the Appliance Standards Awareness Project, which published the model bill, the 2050 Partners Representing California Investor-Owned Utilities, Energy Solutions, which crafts utility incentive programs, administers California Title 24 rulemakings, and administers the state's Appliance Standards Database for compliance certification, so the SASD database. And then, of course, AHRI and its members through consensus internal committees. The Fan Efficiency Project, on the left you'll see the individual states, New York, Oregon, and others, each moving forward with their own fan efficiency requirements. So the big concern is without coordination, this would eventually turn into 50 different versions of almost the same rule, which is everyone's least favorite kind of consistency. The inconsistent kind? Yeah. In the center, AMCA and its partners developed an ASAP model bill for state regulations. So think of this as more of a starter template. It's a common foundation where states can use instead of reinventing the wheel or the efficiency metric every time. So on the right, you'll see the two technical committees that did the heavy lifting, and then the different components of the model bill. So scope, test procedure, minimum efficiency levels, so meaning FEI and then CFM per watt, and then the compliance certification and enforcement. So these components, the two groups were kept separate because, again, the applications and technical issues were different. So until we could bring them together under the context of the model bill. And the next slide, we take a look at more of the purpose behind fan efficiency regulations. So how do we put it to use? So it's not just a concept, but it's meant to be more of a practical tool. On the left, you see the primary places where fan efficiency requirements show up. So for example, IUCC, ASHRAE 90.1, state codes, and then of course utility rebate programs. In the middle, AMCA translated the unification work into two concrete outputs. So AMCA code change proposals and then AMCA design guidance. So one feeds directly into ASHRAE 90.1, IUCC, and state energy codes. The other is a utility incentive program, again, that developers can use when creating rebate guidance documents. On the right, you'll see AMCA International serving as the technical anchor. So AMCA brings consistency by aligning, once again, scope, test procedure, minimum efficiency levels, and then AMCA certified ratings program. So the AMCA Fan Efficiency Regulation Unification Project, the basis for the decisions, it was meant to be achievable. So 1 year grace period for state regulations, not 5 for US DOE first-time regulation. It's supposed to be simple, so a very simplified model that's easy to follow because states have limited expertise when it comes to fan regulation, limited budgets, and definitely limited resources. The goal was harmonization or to create a uniform model, so between states and within states for regulations and energy codes. That way we don't have the patchwork regulation, so in other words, different regulations for each state. So what's next? The ASAP model bill, which Michael's going to go on ahead and go over the different components with you. Thank you, everyone.
All right, thank you. And allow me also just to do a quick introduction. We also have a new manager of education at AMCA, so this is the foundation of a lot of good things coming forward from AMCA. So let me introduce Gordon Kalabek, just joined AMCA recently. So this is his first AHR Expo. I think, Brittany, this is your first as well? It is her as well. So they're rising stars within the AMCA organization. It's a pleasure working with them and having them here today. So let's talk about what's in this model bill. So the model bill really is something that has existed long before this issue. It is the way that this organization, it's a NGO that promotes energy efficiency regulations. They're an offshoot of ACEEE, American Council for an Energy Efficient Economy, and they have this model bill that they push out every year to state legislatures for filling in the gaps of DOE regulations. So bathroom exhaust fans, for example, and I can't remember all the ones off the top of my head, but there's like 10 or 11 different products, at least, that are covered in this model bill, and our goal was to add a fan provision to it, which is what we did. So Brittany did a great job at describing how we did it. Let me tell you what's in it. And again, I'm really proud of this for the group, for our industry, because again, we finished something in a year, picking up where DOE left off after more than 14. So what's in it is that air circulating fans will have an equation-based minimum standard based on diameter and airflow. Even the DOE energy standard that was proposed at the time, we came up with a better way of regulating those fans than they did, but we didn't have it done in time to create the actual equation with the parameters, and now that's done. We also established a minimum fan size at 200 watts. The DOE test procedure begins at 125 watts because there's an IEC standard for circulating fans that ends at the higher range at 125 watts. The DOE test procedure picked up from there to create commercial and industrial. We upped it even more to 200 watts to provide greater separation between residential and commercial industrial circulating fans. So that was really good. But just if you make those fans, know that if you test between 125 and 200, you're still required by DOE to test to that procedure. They're just not going to be covered by the energy standards that might be in this model bill. And there's going to be an energy codes that pick this up too in some cases. The applicability, again, in terms of keeping things simple, this regulation only applies to fans, commercial industrial fans, FEI fans to be succinct, that are selected using manufacturer selector software. So if you've got, if you have stocked fans in a warehouse, they're generally not covered, okay? But if an engineer makes a fan selection and they have the duty point, and you get the fan table and you pick what you want and all that, those are the fans that are covered because you can't really enforce a regulation for stocked items and things like that, not for the FEI metric. The embedded fans, so fans that are included in packaged equipment like air handlers and rooftop air conditioners, what I can call AHRI equipment or ASHRAE equipment, things that are in the efficiency tables, but basically fans that have a purpose other than air movement that are installed in other products, those fans are completely exempt. So California did a really good job of crafting language to exempt embedded fans. If you're covered by the DOE test procedure, you still have to test those fans to the DOE test procedure. But again, in terms of the model bill that might create a fan regulation, those fans are exempt. That's a big deal. It really is. And then also the FEI minimum, another big deal, this is huge, is that it's 1.05 for all covered fan types, okay, that are within the requirements cited in the DOE test procedure. So if you're familiar with ASHRAE and IECC, you know that the requirement is 1.00 for constant speed and 0.95 for variable speed fans. 1.05 is above both of those numbers, so it is in fact a higher requirement, a more stringent requirement than what's in the current energy codes. So that was good. But the simplicity of having 1.05 for all fan types compared to where DOE was going, where they had a table, 9 different fan types, some duplication, but all of those fan types had their own FEI level. And then DOE also had 2 different multipliers, right? So you had an A multiplier and a B multiplier. So it was really hard to tell from reading the regulation what was your actual requirement. With the model bill, the simplification is this 1.05 for all fan types. That's a huge, huge, huge win. Okay, and that's going to be the basis of a lot of the unification efforts moving forward when we make proposals into the model energy codes and all of that. So anyway, really good work from all the groups that participated in that major decision. In terms of filing, the simplified requirements relative to California. California's table of required parameters that you have to file is around 24 different parameters. The structure of the model bill was not one that we could put in the parameters that you have to file. We have to provide some guidance documents down the road, but there's going to be like 4 or 5 different parameters. The FEI rating is not going to be one of them because it's usually a parameter that's calculated during the selection process, so you can't really put it in a compliance table. But there's going to be enough in there to have some teeth. There's going to be, since it's coming out of AMCA, I could say it will have a parameter called AMCA certified, yes or no. The reason why we put that in there is to facilitate rebate programs in the future where we envision that only AMCA certified products will be eligible for rebates, and the certification tables for the regulation might be an easy way to find out where those fans are, right? Got it. Good. We got some folks from Energy Solutions here, and they're helping us with rebate programs. So anyway, also, out of scope. So California, when DOE did their test procedure, they created 2 major classes of embedded fans. Air curtains, they treated as an embedded fan. Those are excluded. and it's really, really complicated. So embedded fans over here covered, embedded fans over here not covered. The model bill, California did a really good job of exempting both of those categories, and the model bill picks up that language, as well as a whole bunch of other things like laboratory exhaust fans, explosive-proof fans, fans that are in corrosive environments. So there's a lot of language around what's exempt for these specific characteristics. And then we also went a little bit step further. Material handling fans. There's a couple of kinds of radial fans that are shrouded that would have been stressed out over a 1.05 FEI. I mean, they're not meant to be efficient. They're meant to handle equipment. They're moving wood chips, right? So what you didn't want to have is a requirement that would put non-material handling radial fans in a material handling environment. They'd just get chewed up, right? So the powers that be, the people involved in this recognize that. And so they created two new definitions that don't exist anywhere else for this model bill so we could exempt those kinds of fans. And then in terms of size range, it's the same sizes that are in the DOE test procedure, that are in California, that are in the model energy codes. That's all consistent. So that in two tables is where we are, what I would consider the acme, the apex, the pinnacle of more than 14 years of regulatory exercises around commercial industrial fans. And again, I salute the industry, I salute our collaborators on this, the fact that we got this done in less than a year, and that this model bill was done in time to affect the upcoming 2026 state legislators that are now beginning to craft their efficiency regulations. So DOE pulled out in 2026, and we got this done in, they pulled out in 2025, we got this done in time for 2026. That was a major effort. Again, compliments to the collaboration that went behind that. So let's talk about what's going on in model and state energy codes. All right, so start with this. So I crafted this table to show that you're aware that in model energy codes, states adopt a model energy code, and they might refine it here and there, nip and tuck, to craft, tailor that model code to their construction practices and climate and things like that. That's the purpose of the model codes. Well, an issue with that is that an old version of a model code could remain in a state energy code for a very long time. So FEG, the first fan efficiency metric provision that appeared in AHR 90.1 in 2013, that metric is now outmoded, but the 2013 edition of AHR 90.1 is still in place in some states. FEG appeared in the IECC, International Energy Conservation Code, first time in 2015. Both of those editions were updated, and 3 years later, so 2020, I'm sorry, that's a typo. That should be 2016, not 2026, darn it. And then IECC 2018. So, those older editions are still in play. The fan efficiency grade metric is still in play in different states. And then also FEI first began to appear in state energy codes, model energy codes in 2019 with AHR 90.1 and an IECC in 2021. So in 2019, 2021, FEI began to appear, and it's taking a while for that new metric to wash through the different state energy codes. And then along comes the DOE test procedure. As we mentioned, it took effect in 2023. The impact of that is that the FEI metric became the law of the land. So even if a state energy code references the FEG by law, even if you have to provide an FEG requirement, the manufacturer also still has to provide an FEI rating for that fan as well. So a code official might ask for FEG, that's fine, but the manufacturer still has to provide an FEI rating. So what that meant is that when we updated the model energy codes for 2025 and 2027, we had to change the reference standard from AMCA 208, AMCA standard 208, to the DOE test procedure. It wasn't easy. You just think you could say, take this out, put this in, but no. Not only in 2025 did DOE withdraw the energy standard that was going to be a final rule, about May, the current administration's Department of Energy surprisingly put out 24 notices of proposed rulemakings or draft regulations that were proposing to remove fans and 23 other products from federal regulation, okay? So what they were trying to say was, for fans, we'll limit this to fans, was that, hey, when we decided that fans coverable by the Energy Policy Conservation Act or EPCA or, forget it. Well, we made a mistake. There's no energy savings there. We're just going to remove them from federal regulation. Now, that was a very bad thing for the fan industry, because what would happen is, as Brittany showed in that cartoon, was that they're essentially saying DOE doesn't want to regulate fans anymore, but states go for it. It allows the states to create their own, because a federal preemption would make a uniform requirement across all the states. So when the previous administration withdrew the energy standard, and then the new administration is threatening to remove that test procedure, this just throws everything back too far. So we're working against that. But because midstream through the code update cycles, we had already put in proposals to change from AMCA 208 to the DOE federal procedure, we had to update all those proposals to create some hedge language in case DOE actually did remove fans from federal preemption, and therefore the test procedure would have gone away. So we don't think it's going to happen. They haven't made a final decision, but if they do decide to pull out fans, those references will just revert back to AMCA 208. So this is a pretty useful table. Just change the 26 to 2016 and move on. What this looks like in a state map perspective, as of June, 15 states continue to use the fan efficiency grade, FEG, in their state energy code. 22 states have FEI, and a bunch of other states, 13 I think it is, have either no energy code at all, or they're called a home rule state, where the energy code varies by city. It's just kind of vague as to what energy code is in place where. So we just kind of count those out. So in general, this is what it looks like, and this is why we say things are a mess, is because what we really want in terms of energy codes is for things to look like this. One metric in all the energy codes. That would be great. The white states, don't have an energy code, and the gray states are home rule, or they have an energy code so old it doesn't have a fan efficiency provision at all. Maybe those states will kick in at some point, but in general, this blue color is about the best we think we can do for having a uniform fan metric in all the state energy codes. So there you go. And what else is in the energy codes? Well, as I was mentioning earlier, we didn't put any proposals in to change the minimum FEI requirement. They're still the same as they were back in 2019 for ASHRAE and 2021 for IECC. But you can see that instead of having two different levels, the model bill, we're going to be putting in proposals in the future to make that uniform 1.05 for all fans. In terms of the size range, what's in the energy codes is consistent with what's in the model bill. No changes there. In terms of the covered fan types, so I want you to notice here that there's 6 different fan types that are centrifugal fans, and the only change that is worth mentioning is that the model bill has those 2 refinements that I mentioned about housed radial fans for material handling are exempt from the model bill. To the extent, I don't think that those fans are used, Doug, in energy, they're relevant to energy codes in commercial buildings, probably not material fans, so no relevancy for this discussion, but I want to show you that there's one little bit of definition changes for those. And then there's 3 different axial fan types that are covered by the energy codes, and those are consistent across in the energy bill as well, in the model bill as well. But a funny thing, and then for circulating fans, there's housed axial and unhoused axial fans. No change in terms of fan types. The biggest thing to mention here is that in the energy codes, the minimum size is also 200 watts as it is in the model bill, but the DOE test procedure starts at 125 watts as well. So going back to things, there's 9 different fan types, and if you look at, a person like a code official or a state legislator, if they look at a fan and they see, oh, is that a centrifugal roof, power roof ventilator exhaust, or is that a centrifugal power roof ventilator supply, or is that a centrifugal unhoused fan, or is that a centrifugal inline fan? People who don't really know a lot about fans will have a hard time distinguishing them from looking at them. So if a fan washed up on a beach, would you know what kind of fan it is? We had a lot of that discussion during the rulemakings, So we spent a lot of time on definitions. In order to cover something in a regulation, you have to define it. So you really know legally what that thing is. And then in order to exempt something like a PPV or a lab exhaust fan, you have to define that explicitly too, so you could exempt it. So there's a lot of effort going into defining fans and distinguishing fans from one type or another. But the common thing that we talked about during the rulemaking discussions was if a fan washed up on a beach, could you tell what it is? Well, the same is true when you look at a table of fans. And this is where the Washington State Energy Code decided to mimic the draft DOE energy standard. Okay, so DOE came out with their draft energy standard in January 2024. And it really created a ruckus because instead of having one FEI value for all the fan types, they broke out 9 different fan types and they created an FEI value for each of those, as well as, multipliers and things like that. And even though they withdrew the standard, the draft is still in the public domain, okay? And so we were concerned that states would begin to replicate that table. We didn't like it. And one state did. Okay, before we could get the model bill thing going and done, Washington State, their code cycle had deadlines such that this squeaked in, okay? And we learned about it one day before the deadline for the proposals, and, we freaked out and called the people that were doing the proposal, and we talked to them, and they were very, very reasonable. And we worked with Washington State code officials, the people on the committees for the energy code, and we were able to get the actual FEI values down and to simplify the table back to be more closer to the model energy codes. But this one squeaked out, so the Washington State Energy Code is the only energy code in the country that has this table. And we really hope that instead of using tables, when other states look at their energy codes, they pick up the model energy bill, because would you rather have this to deal with as a code official or that? Okay, and that's one of the powers of the unification project, because we brought a lot of the right parties together to really to tell the industry, the code arena, the regulatory arena, that the simplified method is the best way to go for all concerned. In the model and state energy codes, there's a lot of exceptions. There's 11 different exceptions. There's not enough time to go into those in detail. I did go into detail I have some bonus slides at the end that you're not going to see, but if anybody wants a copy of the presentation, let me know, you'll have them. But I do explain each of the exemptions, what that means in there as well. And then also fan arrays. So in the energy codes, fan arrays are covered. And when DOE created their test procedure, they didn't create a way to calculate an FEI for a fan array. What they ruled was that every individual fan that makes up a fan array, they're all the same fan, right? So your box fan has to be tested and rated in accordance with the DOE test procedure, but just the fan, not the fan array. But AMCA has a standard, AMCA 208, which defines how the FEI is calculated. We have an annex in that standard that tells you how to calculate a fan array FEI. So in the energy codes, they reference that part of AMCA 208. So that's a cheat sheet there. So this table presents a really quick way to see just how unharmonized the energy codes are. So in the left-hand column are the different codes. There's the ASHRAE 90.1 2025 edition. There's IECC 2027. There's the Washington State Energy Code that's just coming out, Idaho Energy Code, which is being revised for the first time in a very long time, and the Florida Energy Code. So what AMCA has been trying to do during code cycles is harmonize these provisions as much as possible. We want them to be consistent as much as possible. And sometimes it's just impossible to do that because they all have their own language some way or another. But at least, if you look at the first column, they will all have the same reference, which is a huge win. So they're all going to reference the DOE test procedure, right, and have the hedge language in case DOE withdraws it. So all the test procedure references are going to be the same. We're introducing the air circulating fan for the first time in model and state energy codes in these new additions. And in doing so, only Idaho balked. When Idaho decided to update their energy code, they had one rule, okay? And that was the new edition had to have the same number of words as the old edition, okay? Right? So it's like, wow, okay. So we were told with our proposal, they said, look, if you take out the air circulating fan stuff, we can get in the FEI stuff, okay? Because they were using FEG at the time. We wanted to at least switch to metric and all that. So we said, sure, no problem. So that's why that, code pink on Idaho in the ACF reference standard. And then also, that carried through across the other columns as well. Minimum efficiency. So when we had our equation for calculating the minimum efficiency for a circulating fan, really good work on that. That was an awesome thing. Because we weren't able to do the scalar calculation analyses required by ASHRAE and IECC, they wouldn't accept our proposal for a minimum efficiency standard for those fans. But Washington State and Florida did. So cool, we got that in, and we'll work on trying to do the research necessary for that. But the market data for air circulating fans is really sparse. I mean, it just is. It's really hard to do that without guessing. So that might take a while, but that's okay. FEI and ACF in construction documents. So this was a new proposal, okay, where what we wanted was for when you have a fan schedule of FEI ratings for all the different fans that you have in your design, and all, you want those FEI ratings to be carried into the construction documents. And without that, it's really hard to enforce. So that language actually got in, and we're real happy with that in most of those cases. And then the last one is the stickiest one, okay? So IECC really has good language around what it means to have a label on a product. Labeled means tested by an independent laboratory and labeled by the manufacturer, but the labeling really amounts to a third-party certification. And IECC has had that, on FEI and FEG, since 2015, since all the way back. So that kept through. But ASHRAE's a real stickler on this, and they won't let it happen. They didn't let it happen this time. We're still working on this. This is really an advocacy challenge for AMCA, is to have third-party certification required for fans. They have it for other products, right? A lot of, AHRI products and things like that, they're in a table, and that table has certification in it, and it's really kind of crazy how that wording works out. But we are working on this, and we think that there's a path forward for having third-party certified fans in ASHRAE 90.1 in the future. But meanwhile, it is across the board. It is in the different state energy codes. That's really, really good. So that's really, really important, which leads me to cutting back to the chase. As I started, you can see that there's a lot of inconsistency in regulations and in energy codes, model energy codes, state energy codes, and honest to God, really, the best way to cut through that, the best way to protect your designs is to require third-party certification for fans. Now, it just so happens that AMCA is the only one that's certifying commercial industrial fans. So AMCA certification is what you would specify. And know that when you do this, generally it's the software that's certified for FEI. FEI ratings are very complex. All right, so if you've got a fan and it's got different impeller configurations, different housing configurations, different material configurations, motors, drives, and appurtenances that are used when they rated the fan, when all those things vary, you need software to calculate the FEI, because the FEI is different for whatever configuration you come up with. So FEI is generally provided by software. AMCA certifies the software. So if a manufacturer says they have AMCA certified FEI ratings, they're generally referring to their software, which is what you want to do. And we made it easy to find, and make sure that if somebody claims to be AMCA certified, you can find that fan on our database. So I look at it like this. As I mentioned earlier, certified products, give you greater confidence that that product will perform as rated, that your system will perform as designed, that your building will achieve the performance requirements that the owner set, and then everybody's happy when all that happens. So certified ratings is kind of like on the ladder for making that happen. Now this is the language that you should take a picture of. This is the one that I want you to go home with, where in your specs you put in all, centrifugal fans, axial fans, any fan that could have an FEI rating, basically, she'll have an FEI rating greater than or equal to X, where X is what's required in the model, in your energy code or your energy regulation. That's your minimum. You can make it more if you want. Like if it's a really critical energy hog application, you want it to have an FEI rating that's higher than the code minimum, that's where you put it. And And then you also want to specify air performance, sound performance, and FEI, all that together. So that's the trick. And then the other thing too is holding your spec. When I was a magazine editor for HPAC Engineering, I visited an engineering firm in New York City. I spent like 2 days just hanging out with those folks, those professionals, and watching them design and specify. And I was in one of the vice president's office, and we were talking, and all of a sudden his phone rang. He goes, I got to get this. It's a big project. I said, okay. So he gets on the phone, and all of a sudden his face turned beet red, and he's screaming into the phone, rah, 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 rah. Then he hangs up the phone, and he laughs, he gets this big smile. He goes, some contractor tried to do a substitution, because I love when they do that. I tear them up, So basically what he was trying to teach me was engineers, not after they do a project, it doesn't let go until it's done, that they really have to hold their spec. And so I encourage you to do that as well in your projects. So with that, ladies and gentlemen, I'll bring it back up here, and we can do some Q&A. We got about 10 more minutes for your questions. So please, fire away. Thank you. Oh, and there's that, but I wanted to mention, it's not in here, rats. Yes, you can take a picture of this. If anybody wants a copy of these slides, let me know. Just give me your card, whatever, and we'll give you a copy of these slides, no problem. But with that, I want to let your PDHs happen as well. So questions, please. Don't leave us hanging. Okay. Well, you're free to go. Thank you very much. Have a good day.
Thank you.